Okay, so this one, it's actually, we did a little bit of this section before, because when we were solving right triangles, we had to learn how do you solve for the angle. And we had a little bit of homework from 13.1 and a little bit from 13.4. But most of 13.4 we didn't look at. Okay. Now, really the whole way this is presented in the book is, to me, a little bit odd, because I really want to talk about the graphs of the sine and the cosine before I talk about this. And actually, that's in chapter 14, comes way after this section. But you'll see why I would like to talk about the graphs. So you don't have to copy all this stuff down, right? The meat of the thing will come in a few slides. But first, we have to review what is an inverse, right? We know that an inverse of a function has to exactly undo the original function. So if f of 1 equals 2, f minus 1 of 2 equals 1. And then we take something, we dealt with this one before, like f of x equals x squared, right? We substitute y for f of x. We switch the x and the y. We solve for y. And we get y equals, or f minus 1 of x equals plus or minus the square root of x. So for example, if I find f of 2 up here, I get 4. But if I find f minus 1 of 4, I actually, because of the plus and minus, I get plus or minus 2, which means that the function and the inverse are not exactly undoing each other, right? I can find f of 2 is 4, but f of 4 is also negative 2. So we would say that this right here does not have an inverse. Now graphically, if we graph a parabola, right, the parabola looks like this. We said that in order for any function to have an inverse, it must be the case that the graph of the function passes both a vertical line test, which means that function is a function, that graph is a function, and a horizontal line test, which means the inverse would have passed a vertical line test. So it's got to pass both. Okay. Now, if we look at the trig functions, just using the unit circle, we could say that the sine of pi over 6 is a half. But is the sine inverse of 1/2 necessarily pi over 6? You could take out your unit circle and look if you want, but here's the circle, right? The sine of pi over 6. Pi over 6 is right about there, right? The coordinates are √3 over 2, 1/2. And that's why the sine of pi over 6, the y coordinate, is 1/2. But actually, just on the unit circle, I could go straight across to this side, and the coordinates of that point are negative √3 over 2, positive 1/2. So what is the sine? The sine of 5 pi over 6, it's also 1/2. So just like I did with the f of 2 is 4, but f minus 1 of 4 is plus or minus 2 with the x squared. The same thing happens here. Sine inverse of a half would either be pi over 6 or 5 pi over 6, which would tell you that the sine function, it does not have an inverse because of what happens when you take the sine inverse. Right? I mean, just look at the graph of the sine. I think I got a graph from negative pi to positive pi. And you can see that it would definitely pass a vertical line test, but this would not pass a horizontal line test. But looking at your calculator, that we clearly have a sine inverse button on the calculator. So you've got to do something in order to have the inverse function work, right? So the domain of this is all real numbers. The range is -1 to 1. Right? That's what would have happened if I flipped that function, like you do when you take an inverse, right? Flipped across the line y equals x. Instead of the wave going this way, the wave is going this way. And that clearly fails vertical line test. So this is how we solve that. instead of using the entire domain of the sine function in order to come up with an inverse function, we're only using from negative pi over 2 to pi over 2, right? If you only look at that piece right there, would that pass a horizontal line test? It does. By limiting the domain to negative pi over 2 to pi over 2, now it passes the horizontal line test. So now, I kind of, in a way, don't like what I wrote right there, because I still got y equals sine x, and it says the domain now is negative pi over 2 to pi over 2. Really not quite true. I mean, the sine function still has a domain of all real numbers, but we're just trying to construct an inverse function here. I mean, notice that the piece that we chose right there, it has all the possible values of sine, right? It starts at -1, and it goes all the way to +1. So we have everything we need. We just don't repeat any of those values. Okay. So now we look at y equals sine inverse. Remember what happens when you take a function and its inverse? You swap the domains and ranges. The domain of the sine inverse is -1 to 1. I mean, you can take the sine inverse of values in between -1 and 1. You can't take the sine inverse of values above 1 or less than -1. And you will always get values. I say negative pi over 2 to pi over 2, but most of the time we're actually dealing in degrees. Right. So, you know, understanding cosine has exactly the same problem, right? It repeats itself over and over again, so you can't use the entire domain of the cosine when you're coming up with a cosine inverse function. It just that, so the sine inverse we usually limit to negative pi over 2 to pi over 2, which means quadrants 1 and 4. Okay. You copied this when you did the key concept blocks. That was those 3 graphs that you were copying. For sine inverse, quadrants 1 and 4. For the cosine inverse, we have to use quadrants 1 and 2, right? Cosine is positive in quadrant 1, negative in quadrant 2, right? But it doesn't repeat itself that way. And tangent is the same as the sine, right? It's quadrants 1 and 4. If you only use those 2 quadrants, you get all the possible values of sine. You don't repeat them at all. Therefore, it'll pass vertical horizontal line test. So let's notice, so the domain of the sine and the cosine inverse is -1 to 1. Right? The range is where we go to the quadrants. The domain of the tangent inverse is actually all real numbers. If you remember the graph of the tan inverse, or the tangent, there was like these branches that looked like this. Each one of those had all real numbers. So when you flip it, then the domain is all real numbers. And you'll see, you could take the tan inverse of any number at all. You get an answer. You can't take the sine inverse or the cosine inverse of anything at all. So the main thing to keep in mind right here now is these, probably just in terms of quadrants, right? 1 and 4, 1 and 2, 1 and 4. Okay, I remember now. Here we go. Finish your ready. Right. I'm just joking. If other people probably see it. Right. Here we go. So, evaluate. Now, in these cases, you're going to recognize some of these values as these are coordinates on the unit circle, right? So we're going to expect to get answers that are angle measures from the unit circle. Now, personally, when I look at like cosine inverse of the square root of 3 over 2, in my mind, what I'm saying to myself is, at what angle does the cosine equal root 3 over 2? That's how I say it to myself. At what angle does cosine equal square root of 3 over 2? Okay, well, again, I do this just by thinking of the unit circle. So I'm going to draw a circle. And I know the square root of 3 over 2, that's the bigger of the two. It always is paired with 1/2. And so that means you're going to be like here, right? Because then the x coordinate is more than the y coordinate. That has the coordinates of root 3 over 2 and 1/2. Right, that's pi over 6. Now, where else between 0 and 2 pi does the cosine equal root 3 over 2? Which quadrant would it be in? Where else is the cosine positive? Remember, cosine is like saying the x coordinate. So which two quadrants is x positive in? No, 1 and 4. Straight down, right? You look at your unit circle. That would be square root of 3 over 2, negative 1/2, right? It's the y that's negative down there. And that's 11 pi over 6. Right? But by what we just learned, when you take the cosine inverse, you're only going to take answers that are in these two quadrants. So the only answer there is pi over 6. Remember, cosine has to be in quadrants 1 and 2. Cosine inverse. How about the sine inverse of 2? What's the domain of the sine inverse? We just had that on the previous slide. Negative 1 to 1. Is 2 in the domain? Okay, I mean, you could try it in your calculator. Try to do the sine inverse of 2. You get an error, right? Because it's not in the domain. I forget how the book calls these again. But I know I've seen this before. You just say like D and E does not exist. Can't take the sine inverse of that. Okay, how about the tan inverse of negative square root of 3? Remember, how do we come up with the tangent when we're looking at a unit circle? It's the y over x, right? It's a combination of the coordinates, which may be kind of hard to visualize where that comes from. But what I like to do with that is take the negative square root of 3, right? And divide it by 1, right? And then divide both of them by 2. And now you've turned it into the square root of 3 over 2 and 1/2. That's actually what we usually see on the unit circle, not just the square root of 3. So like this could be negative square root of 3 over 2 over positive 1/2, or it could be positive root 3 over 2 over negative 1/2. Either one of those would have that same negative square root of 3 when you divide. Okay, so where is that on the unit circle? So if y is negative square root of 3 over 2, that's down here. If x is 1/2, that would make it right there. So that is, I'm not even going to rewrite that. What is that? 2, 3, 4, 5 pi over 3? No, not 5 pi over 2. 5 pi over 3. Okay, so the other one would be positive, the y is positive, right? And the x is negative 1/2. That would be right there. Which is actually, and this will come up later, that's exactly 180 degrees around the circle, or plus pi. And that is 2 pi over 3. Now, only one of those is in the range of the tan inverse. Which one is it? The 5 pi over 3. Remember that the tangent only goes in these two quadrants. So that has to be 5 pi over 3. Okay. Okay, now now this is your U try. So do the U try, see if you could figure out these. So where does sine equal positive root 2 over 2? Here and here, right? So we can only take it in quadrants 1 and 4, so that we're going to go for pi over 4. Okay, how about tan inverse of negative 1? Meaning, where does tangent equal negative 1? You're dividing a y by an x. So what does that tell you about the values of y and x? They have the same absolute values. They have opposite signs. So what are the coordinates of the points where they have actually the same x and y values? Yeah, all the pi over, right in the middle of each quadrant, right? You've got one point which is either like root 2 over 2, comma, root 2 over 2, or one of them is negative, or both of them are negative. So tangent would be that way here and here. Okay. And, you would call this one is definitely 3 pi over 4. That's not in tangent. We only take in these two. And this one can be, the truth is we're supposed to take these values between negative pi over 2 to pi over 2. So that would actually make this one negative pi over 4. Negative pi over 4. What else? You could call it 7 pi over 4 if you want to keep it between 0 and 2 pi. But usually you would say negative pi over 4. Okay, what about cosine is negative 1/2? Where does that, or is positive 1/2? Where does that happen? Right? Cosine being positive 1/2 means that it's either here or here. And in between, in quadrants 1 and 2, it has to be there. So what angle is that? Pi over 3. Okay, how about where does sine equal negative 1/2? Yeah, either here or here, right? Which you could call that point 11 pi over 6, or negative pi over 6. Okay. So I think now what we're going to do is 6 slides left. We're going to do a sine inverse. We're going to do cosine inverse. We're going to do tan inverse. One for me, one for you. And these are things, generally they cause us a little bit of trouble, right? That you have a hard time wrapping your brains around this. So just try to pay attention and take some good notes. And the homework problems, you'll get them. So the sine of theta is negative 5/8. So it says find the angle theta where the sine of theta is negative 5/8 and where theta is in between 180 and 270 degrees. What quadrant are we in if it's between 180 and 270? It should be the third quadrant, right? Q3. Okay. So we need to take the sine inverse of negative 5/8. Theta equals sine minus 1 of negative 5/8. Okay. Now, because the domain for theta was given in degrees, we're going to do this in degrees. So you should have a calculator set on degrees. So let's go ahead. Sine inverse of negative 5 divided by 8. Negative 38.7. So if I look at that on the circle, which quadrant is negative 38.7 degrees in? It's in the fourth quadrant, right? Maybe it's about right here. I'm just estimating in my graph. That's negative 38.7 degrees. But we want to find in quadrant 3, where does sine have that value? So how am I going to do that? I'm going to go straight across, right, on a horizontal line to that point right there. So how do I find the degree measure of the angle that is right there? Say again? Add 90 degrees? No. I mean, if this is 38.7 degrees to here, then how do I find the angle measure to get to there? Yeah, you take 180 degrees and you add 38.7. Right? And that is 180 plus 38.7. 218.7. Now there's some rounding going off, right? Because it was actually negative 38.68218.745. So this is not going to work like to the nth decimal place. But now try to take the sign of 218.7. See what you get. 218.7. I'm getting negative 0.625. Okay, what is negative 5/8 as a decimal? Negative 0.625. So that is the same. So in this case, we got a sign that we had to go from quadrant 4 to quadrant 1. And you could see how we did it, right? Since that number of degrees was the same number of degrees, we had to go past 180 to get to the 218.7. Okay, try to do this one. Sine is 0.52 between 90 and 180. So theta equals sine inverse of 0.52. So theta equals 31.3. Okay, if I draw my circle right there, 31.3 puts me about right there. Okay, but this here, that's quadrant 2. So how do I find the place in quadrant 2, which is that same distance above the x-axis? You subtract 31.3 from 180. There's 180, right? You're going to go that way. So theta is 180 minus 31.3. $148.7. Again, you could check it. You can check by, let's take the sign of 148.7. And I get 0.52. So sure enough, that's the other place where sine has that same value. Okay, that's the sine. Now we're going to do cosine. All right, cosine, find the theta where cosine equals 0.4 and theta is between 270 and 360. So first step, theta equals cosine inverse. Now I'm getting 66.4. So if I draw my circle, 66.4 is about right there. Okay, but this is quadrant 4. So I need to find where in quadrant 4 would cosine have the same value, meaning the x-coordinate is the same. It's the same distance to the right of the y-axis. How am I going to find that angle measure? Subtract from 360. Exactly. Right. So just take your 360 here, and you go backwards, 66.4 degrees. So theta equals 360 minus 66.4. Theta equals 0.52. 293.6 degrees. Again, check it. Cosine of 293.6.4. So it works. Okay, here's your U try for cosine. So did you get 119.3 degrees? Okay. Again, I'm going to go to draw myself a circle just so I can understand what I'm doing. 119.3, what quadrant would that be in? Should be in the second quadrant, like about right there. Right? So I'll call that 119.3. Okay, but this is actually the third quadrant. Right, so how am I going to find the angle measure in the third quadrant that would have that same exact cosine value? Okay, so if this is, 119.3 that way, if you start at 360 and you go backwards, 119.3, you ought to get there. So let's try that. Theta equals 360 minus 119.3. $240.7. 240.7. Again, I'm going to check it. Cosine of 240.7 is negative 0.49. So that's good. All right, so that's sine and cosine. We've done those. Now we do tangent. And tangent works out differently than sine and cosine. So let's do tangent of tangent theta equals negative 2.1. So theta equals tan inverse of negative 2.1. Again, notice that you can take a tan inverse of a number bigger than 1, right? Its domain is all real numbers. So second tan negative 2.1. Negative 64.5 degrees. So let me visualize that. What quadrant would I be in if I'm at negative 64.5? Fourth, right? So I'm down maybe about right there, I'm going to estimate. Okay, now this is in quadrant 2. So the way you find the place in quadrant 2, which is exactly going to have the same tangent value, is you add 180. If you add 180 degrees, that takes you exactly across the circle. And 15.5. So remember that for the tangent is the y divided by the x, right? In this case, if you're down here, the y is negative and the x is positive. If you're up here, the y is positive and the x is negative. But as far as the distances go, that's the same distance as that. That's the same distance as that. So when you take the ratio y over x, it's the same. So if you're in this quadrant and you need to get over there, you add 180. Right? Let's try this one. And then we're done. Try to do that one. So everybody gets 78.0 first, okay? And then you said 78.0 would put it about right there. Okay, so this is quadrant 3. So how am I going to find the place in quadrant 3 which has got that same ratio? Plus 180. Again, I can check it. Tangent of 258. 4.7. Okay. So what do you think? Hard, easy? Okay. Good. So that's the homework. Not even a word problem on there. Can you believe it?